Welcome to today's webinar, Building Big Data Solutions with Amazon EMR and Redshift. Our presenter today is Rahul Pathak. Rahul runs the Amazon EMR business for AWS. Amazon EMR is a web service for running frameworks like Hadoop, Spark, and Presto on managed clusters in the cloud. During his time at AWS, Rahul is focused on a managed data and analytics service. Prior to EMR, he was the principal product manager for Amazon Redshift, a fast, fully managed, petabyte-scale data warehouse service in the cloud. He's also worked on Amazon Elasticsearch, Amazon RDS, and Amazon RDS Provision IOPS. Rahul has over 15 years of experience in technology and has co-founded two companies, one focused on digital media analytics and the other on IP geolocation. He holds a degree in computer science from MIT and an executive MBA from the University of Washington. Today with us we also have Radhika Raviwala. We'll engage with you and answer your questions throughout the presentation while our presenter presents. Rahul, welcome. I now pass the floor to you.
Thanks, Ryan, and thanks everybody for coming. Really excited to talk to you today about building big data solutions on AWS using EMR and Redshift. And today what I'm going to do is give you an overview of the services on AWS that make up our big data platform, dive a little deeper into EMR and Redshift, and then walk you through how you might go about using them to build a big data application end-to-end, and then finally walk you through a few customer use cases, and we'll make sure to leave time for questions at the end. So let's dive in. So AWS has a very broad, comprehensive platform for big data. And if you think about big data applications and break them into components, you have a data collection and ingestion piece, you've got a storage layer, and then you have an analytic layer. And from a collection perspective, AWS Direct Connect is about establishing private connections between your data centers and ours. These are private leased lines, 1 gig or 10 gig E. That you pay for by the hour, and they provide a private, low latency, high bandwidth connection. Our customers typically use a pair of them for throughput and availability. Import-export, if you're bootstrapping cold data sets and have to move hundreds of terabytes or petabytes of data to AWS, FedEx can be your highest bandwidth option, so import-export allows you to ship us media. We'll get that data loaded onto S3 and return the media to you. And also we recently added Snowball, which is a ruggedized set of drives, 50 terabytes at a time, that we can ship to your data centers. You plug it in, fill it up, ship it back to us. We actually use Kindles as the shipping labels that automatically update, and there's a secure chain of custody, and then the data's loaded onto S3 ready for consumption. Amazon Kinesis is our real-time streaming ingestion service. So this allows you to fire real-time data of any type at AWS and consume it for real-time analytics or machine learning. There's also the Kinesis Firehose service, which allows you to bring in streaming data, land it on S3, or load it into Amazon Redshift. And we announced Kinesis Analytics at reInvent, which will which will be available soon. And this is about SQL analytics on streams on real-time data. So when we move to the storage tier, S3 is one of our oldest services, and it really forms the backbone of big data applications at AWS. It's the default storage layer for data. It's very low cost and very high scale, so it's 3 cents a gigabyte a month. That works out to be about $360 per terabyte per year. It's designed for 11 nines of durability, and it's a very, very high performance system. A sister service to S3 is Glacier. This is about cold storage. Think of it as a tape replacement. Where S3 is 3 cents a gigabyte a month, Glacier is less than a third of that at 0.7 cents per gigabyte a month, and it's for data that you may need to keep around for compliance or archival, and don't need to retrieve in low latency fashion. DynamoDB is our NoSQL database as a service designed to deliver potentially millions of operations per second on a single table without you having to manage any infrastructure, and it supports both key value and document semantics. From an analytic perspective, there's EMR, which we'll talk about in a bit more detail. This is managed Hadoop clusters in the cloud. Redshift is petabyte scale data warehousing. You can run any custom applications or frameworks on Amazon EC2. Basically, if it runs on a Linux machine or a Windows machine, you can run it on EC2. And then we have the Amazon Machine Learning Service. This is a service that's designed to bring a lot of what we've learned doing machine learning over the past decade at Amazon.com into the hands of developers. And it provides an easy way to bring in data sets from Redshift or S3 or EMR, partition those data sets into training sets and test sets to build machine learning models and then allows you to deploy those models into production either for batch scoring or for real-time responses. And Amazon QuickSight is a service that we announced at reInvent, currently in preview, and this is BI for the cloud with collaboration built in, and an in-memory tier called Spice to accelerate data access to data sources. So as you can see, there's a pretty comprehensive platform for building really the full suite of analytic applications, whether they're about reporting, real-time processing, or predictive analytics. So diving into EMR, EMR is essentially managed Hadoop clusters in the cloud. You can provision clusters from a simple web form or command line interface. You can run a very broad set of frameworks: Hadoop, Hive, Spark, Presto, HBase. Essentially, EMR is about providing access to the Apache Hadoop ecosystem with some extensions to make it work well with AWS. We support a range of pricing models. There's the on-demand model, which is hourly pricing, reserved models where you can get discounts for 1 year or 3 year commitments, typically up to 40% in the case of a 1 year reservation and up to 70% in the case of a 3 year reservation. And we also have built-in integration with the EC2 spot market. And spot is where we have unused EC2 capacity that's available at up to a 90% discount off the on-demand rate. And EMR makes it easy to add these nodes into your cluster when pricing becomes available at a rate that makes sense. We actually automatically monitor the spot market on your behalf. And if nodes are available, we can add them into the cluster dynamically, accelerate your work at lower cost. And when the market moves, we can take those nodes gracefully out of the cluster. We also support HDFS, Amazon EBS, and also S3. So we make S3 directly available as a file system, and we can stream data into execution frameworks without requiring you to hydrate it into the cluster in the first place. And then we support end-to-end security, and I'll talk about security in a bit more detail as we go, but essentially you can run EMR clusters, completely isolated networking. You can encrypt data between nodes, you can encrypt data at rest, and you can encrypt data and read encrypted data from S3. So end-to-end security is really important to our customers and is built in. So deploying an EMR cluster is a straightforward operation. You just go to the AWS console, you can fill out a web form, talk about the number of nodes you want, the types of instances. We provide a command line, and there's also an API that you can use to build applications that use EMR clusters. And typically a cluster will spin up in 3 to 5 minutes, and you can start using it. We support a broad range of instance types for a broad range of workloads. General purpose is the M3, M4 family. If you've got CPU intensive work, the C3 and C4 family works well. For memory intensive work, R3s. And then if you need a lot of local disk capacity for HDFS, then the D2 and I2 instance types are the way you'd want to go. And to any of these, you can also customize the amount of storage you want using Amazon EBS, which gives you access to magnetic or SSD storage. So you can essentially design a custom node for your workload, and we allow you to mix and match node types within a cluster. So a lot of flexibility to deploy the kind of cluster that you want. In terms of what's available in EMR, we support a broad range of Apache projects out of the box. So there's Hadoop, Hive, Spark, Presto, Mahout, a number of base frameworks like Pig, Cascading as well. But fundamentally, EMR clusters are Apache Hadoop clusters. You have full access to them. You have root access to the instances. You can install whatever software you would like to. And we have customers running really a broad range of what's available. And we also have an EMR sandbox where we bring in some newer applications that the community is interested in and make them easy to launch and deploy into EMR clusters. So a lot of diversity, and if you follow the Hadoop ecosystem at all, you know that all of these applications are evolving quickly, and there are new ones coming online all the time. So EMR actually updates the applications available through the service roughly every 6 weeks, so we're always running the latest versions of key components. Another thing to keep in mind with EMR is that we've essentially extended the ecosystem to support AWS services directly. So we have connectors to DynamoDB, to Kinesis. You can use Scoop to access relational databases. We have a connector for Elasticsearch. We have an EMR file system called EMRFS, which exposes S3 as a file system into the Hadoop application stack transparently, so you can run Hive or Spark or Presto jobs directly against S3. And then we also integrate with streaming data like Kafka on EC2 or Kinesis, which we talked about, and then of course with Redshift. So a very comprehensive environment. It allows you to do things like run Spark SQL queries against Kinesis streams directly or against DynamoDB tables. So a lot of flexibility for integrating with different data sources on AWS. But fundamentally, Apache applications, so a Spark job is a Spark job. It just can now have the extended capability of dipping into the rest of the AWS ecosystem. One of the big advantages of EMR is that it allows you to decouple your storage and compute layers. And so a lot of our customers use S3 as their file system directly for their persistent data store. The big advantage here is very low cost. You don't have to replicate your data 3 times like you do with HDFS. S3's got 11 nines of durability built in. The other big advantage with separating compute and storage is that you can run multiple clusters simultaneously on the same set of data without having to copy it anywhere. So this allows you, for example, to have an enterprise production environment, but then to give a data science team their own cluster talking to production data and allow them to do whatever they want without interrupting any production jobs. So a lot of flexibility. It also improves your availability because S3 is available in any of our availability zones within a region. And availability zones have isolated network power and cooling, and so this allows you to spin up a cluster in 3 to 5 minutes in a different availability zone if needed, and gives you very low cost, very high scale capabilities. And for context, we have customers running in the tens of petabytes and higher, and you can size your cluster based on your compute needs, and you don't have to keep adding nodes just because you keep adding data to your data lake. So let me keep moving here. From an EMRFS perspective, what we've done is made it easier to use S3 directly in Hadoop applications. So we've improved performance. We've made it transparent to applications where before you might have just a local HDFS path. Now if you just use S3:// and then your path, you have transparent access to S3. We've also added support for S3 encryption, so you can read and write encrypted data directly. And I'll talk a little bit about that as we get into how you might go about building an application. And then we've invested in providing a secondary index for objects in S3, and this can lead to about a 5x speed up when you're listing objects, and it also provides a consistent view of the data that's in S3, so it allows you to chain jobs effectively. And of course, HDFS is always available either for local storage on the EC2 nodes in your cluster or by adding EBS. So a lot of flexibility in terms of how you operate, and allows you to run at very high scale in that area. So switching to Redshift. Redshift is a relational, massively parallel processing data warehouse. It's petabyte scale. You can have up to 2 petabytes of compressed data in a single cluster. It's actually very scalable, so you can start with a single 160 gigabyte node for 25 cents an hour, and then scale all the way up to 125 nodes with 16 terabytes each for 2 petabytes. We've got hard disk and SSD platforms available, and it's fully managed. You can actually stand up a petabyte Redshift cluster in less than 5 minutes and have a SQL endpoint you can start using. Again, we've got end-to-end security, and I'll talk about that in just a minute, and built-in global disaster recovery. So Redshift clusters are actually continuously backed up to Amazon S3, and you can, with a click of a button, have those snapshots automatically copied to a second region. So if you needed to have time to availability of just a few minutes for a regional disaster recovery purposes, you can just have your snapshots in the second region, stand up a cluster in a few minutes and get going. And I'll talk a little bit more about that towards the end of the presentation. So a couple of things. Redshift is a columnar data warehouse, and that's really designed to deliver high performance and to be efficient about minimizing the amount of I/O that's being done. If you think about trying to run SQL queries at petabyte scale, anytime we can avoid reading a block, we can drive higher performance, and I/O efficiency is really one of the key elements of Redshift performance. And so what a column store means is that instead of your data being stored with each row sequentially on disk, as is common with row-based databases, with column stores, Redshift automatically stores each column independently. So if you look at this sample table on the right-hand side of the slide, say you wanted to get the total amount that was sold. In a row-based store, you'd have to read every single row in the table, and then you'd throw away 3/4 of the data because you're only interested in the amount column. And with Redshift, which is a column store, if all you care about is amounts, all you do is read the amount column. So right there, you've only done 1/4 of the I/O that you otherwise would, and that helps drive performance. And these gains really add up at scale. Another big benefit of column storage is data compression. So if you think about data being stored in columns, it's typically all of the same type. It's relatively homogeneous. And so by storing each column independently, Redshift is able to compress the data in the column very effectively. And compression has two big benefits. One is it lowers your costs because you can typically scale down the cluster that you need. And in real-world use cases, we see anywhere from 3 to 4x compression gains. The other big benefit is that compression actually drives higher performance, because if you think about it, every block that we read might have 3 to 4 times as much relevant data, and the savings in throughput rates more than offsets the decompression cost for the blocks. And Redshift will actually automatically sample data that's being loaded the first time it's being loaded into a table, and pick by column the optimal compression algorithm, and then use that going forward. So on the right-hand side, you see the results of an analyze compression command on a table, and you can see that each column has got a different encoding that's been picked. And so this is something that we definitely recommend that you enable by default. You obviously have the ability to tune the compression if you have better knowledge of the data than Redshift will be able to determine through sampling. But definitely a best practice for designing Redshift tables for high performance. Another technique that Redshift uses for I/O efficiency is zone maps. So we actually keep track of the min-max values in every block, and that allows us to skip over blocks that aren't relevant for a query when the data is sorted. So if you can think about a simple example is, say you have clickstream log data in a Redshift cluster and you want to do a where clause for data between last week and today, we can use the min-max values on the blocks to skip over the blocks that are irrelevant and only get the blocks that are needed. And again, this theme of I/O efficiency is what drives performance. So let's keep going. I think the other big architectural decision we made with Redshift to drive performance was to use direct attached storage and big data blocks. So we have megabyte blocks by default, and then if you think of compression, you might have 3 to 4 megabytes of relevant data in a given block. And then with direct attached storage, we can drive very high throughput rates. So on our larger node sizes, the 16 terabyte magnetic nodes, for example, we can drive over 3 gigabytes a second across 24 spindles to the CPUs, and so you can get very, very high throughput for query performance. And when you put all of this together, you have a very high performance system. And so what you get is, for example, Amazon.com migrated a bunch of their workloads from their Oracle data warehouse to Redshift, and they were running a 100-node cluster, and you can load a terabyte of data into that cluster in just under 130 seconds. And we're able to join clickstream data with catalog data, which in Amazon's case means trillions of rows joined with billions of rows, and get those results back in under 15 minutes. So very high scale is possible, but you can always start small and grow into that. So from a security perspective, I use Redshift as an illustration, but it's really indicative across the platform. AWS has a shared security model, so we secure the infrastructure, and then our customers are responsible for application security. A simple example of that is we can't stop users who choose insecure passwords, but we can secure the infrastructure, and we spend a lot of time and effort doing that. Security and operational performance are really our top two priorities with all things we do at AWS. So if you think about Redshift, you've got a set of processes for ingesting data, loading it into the cluster, encrypting it at rest in the cluster, and then querying. And Redshift allows you to run secure end-to-end. So you can require SSL for your BI applications that are querying the cluster. You can encrypt data before it's ever put onto S3 using client-side encryption. Those encrypted data on S3 is loaded over SSL TLS connections into the cluster. You can enable encryption at rest in Redshift, so this will encrypt every block. We actually use, each block gets its own randomly generated key. We use AES 256. And then each block key is encrypted with a cluster key that's only kept in memory, and the cluster key is encrypted with a master key that's for durability for storage off cluster. And we support different levels of key management, so you can use the AWS Key Management Service, or KMS, but you can also use Cloud HSM, which is our service where we run hardware security modules for you in the cloud, where we keep the systems up, but we have no access to the crypto partitions. And you can also use HSMs running outside of AWS. And one of our customers, many of our customers do this. Nasdaq is one of them, and we'll talk about their use case as we get a little further on in the presentation. Other elements of security that we offer with Redshift, you can run everything inside of a VPC. VPC is our virtual private cloud. Essentially, it's a logically isolated portion of the network where you have full control over ingress and egress, and you can bridge it to your data centers using VPN and extend your private address space into AWS. So you can run a Redshift cluster inside of a VPC. So that gives you network isolation and full control. And then we provide multiple levels of audit logging. So we can log everything that was done at the SQL prompt, every successful login, every failed login, every query. The logs are sent to a secure location on S3 that you control, where we have the right to put, but not the right to modify. So you have a non-modifiable log of everything that happened. We also integrate with AWS CloudTrail, which is a tracking service for tracking all API calls that are made in the AWS environment. And in AWS, you can use our Identity and Access Management Framework, IAM, to control which users can make which API calls on which resources, and all of that is tracked in CloudTrail. So a very comprehensive, detail level view of what's happening in your environment. And then from a compliance perspective, we'll touch on this a bit more later, but we go through a broad range of compliance certifications for our services. Redshift, for example, has gone through SOC 1, 2, 3, PCI DSS Level 1, FedRAMP, which is a federal government standard in the US, and HIPAA for personally identifiable healthcare information. And so broad range of compliance, just because we know it matters to our customers, and and security is a top priority for us as we build our services. So now we've talked a little bit about some foundational elements on the platform. So I want to walk you through how to think about putting these together and incrementally growing a big data application. So if we think about getting started, you probably have a set of databases, and these could be relational or non-relational. These are perhaps running in a corporate data center outside of AWS, or they might be running on Amazon RDS, which is our relational database service, or on EC2. You may have mobile applications, websites that are generating event logs. This is pretty typical for our customers to have a diversity of data sources. And anytime you've got high levels of transactional data, you're probably going to have an analytic workload on its way pretty soon. And you can think about extending this into the IoT space. So you might have smart machines, instrumented sensors on medical equipment or mining equipment. Just becomes another data source. So as a first step, we might think about starting by adding a data warehouse. So this could be batch data, so you can essentially provision a Redshift cluster, connect QuickSight to it for BI. Now I use QuickSight as an example, but you also have the ability to use really any of the available BI technologies that are out there. AWS has a very rich marketplace. If you want to use Tableau or MicroStrategy or Looker, all of these technologies can be easily deployed on AWS. And one thing to keep in mind is it's also easy to query from outside of AWS. So some of our largest customers will run their BI applications on-premise or on desktops and query from there. So a lot of options. This is just an AWS stack for illustration. And for connecting, say, a relational database with Redshift, there's a broad range of options available to you. You can use any of the classic ETL technologies like Informatica or Tunity or SnapLogic. There's some newer ones as well, companies like Flydata that'll provide continuous replication from your database systems into Amazon Redshift. And things like Oracle Data Integration. We have customers using SQL Server integration services. Generally pretty straightforward. The highest throughput way to load Redshift is via S3, so the typical path tends to be get data out of your database, stage it on S3, load it into Redshift, and you're good to go from there. And these are all available on the marketplaces as well. And so once you've got your ETL set up and you've got data coming in, it's coming into Redshift, you can start querying. So now we can think about evolving this and say you want to bring in log data into your system. So you can have your web clients and your mobile clients write directly to S3. Typically this will be raw log data. And you may want to then run a transient EMR cluster that you can spin up in a few minutes and then use that to produce data that's ready for loading into Redshift in the staging data bucket in S3. And EMR makes it easy to spin up a cluster, to run a job, and then spin it down. So if you have batchy ETL workloads, this can be a great way to reduce your overall data processing costs. And so once you've done this, you've got log data coming in continuously, you've got a job running at some interval that will bring that data into a staging form. For example, Redshift will load JSON, Avro, or CSVs. And you can load that into Redshift and keep it going. And all of this can be orchestrated using AWS Data Pipeline, which is a job orchestration service, or the ETL tool of your choice. Talent, Pentaho, Informatica, Tunity generally all support these patterns very well. So now let's think about extending the data warehouse to S3. So for example, one of our customers, Nasdaq, keeps a year of data in Redshift because that's their hottest data, but they'd like to be able to query all of it directly on S3 as well. And so you can spin up another EMR cluster that'll take a job and turn that staging data into a Hadoop query optimized format, either Orc or Parquet. And then that can be then used to, you can stand up a Presto cluster on EMR that can query that data. So Presto is a SQL on Hadoop engine that was developed by Facebook. It allows you to query data sitting on S3 with single-digit second latency. And again, EMR clusters are elastic, so these clusters can be scaled up on the fly. And you can run your SQL queries again, and then connect tools like QuickSight or other BI technologies to Presto using JDBC or ODBC. So now you have a system where you have your relational database data coming into Redshift, you have your log data coming into Redshift, and then you have all of that data also sitting on S3 available to be queried. And if you think about it, Redshift is $1,000 a terabyte a year, so a tenth or less typically of commercial data warehousing systems, but S3 is a third of that. And so if you want to keep a year of data live in Redshift and then keep 10 years of data on S3 but still retain the ability to query all of it, this is a great framework and pattern to use, and it's a very common one across our customers, and we'll talk a bit more about this in a second. So now say we want to add a real-time layer. So you can start streaming data in real time into Kinesis streams. And then you can connect Spark Streaming, again available on EMR, to your Kinesis stream. So you can now process streaming data in real time. That data can be brought in and written into your Orc and Parquet formats. And then that data is now available for querying via Presto. So you can see that we can incrementally start building applications that go from batch single source to very diverse array of sources, and now incorporating batch and real-time layers. And to give you some context, if you wanted to bring in all of Twitter, so 500 million tweets a day into Kinesis, at 2K a tweet, that's roughly 12 megabytes a second of inbound data volume. So that is a pretty small Kinesis workload, and that will run you about 76.5 cents an hour for the Kinesis streams needed to capture that. So now we have a batch and a real-time system bringing data that we can query by using SQL on S3 through EMR, as well as query through Redshift. And now if you wanted to build in some machine learning, you can use MLlib and Spark and start feeding predictive data back into your application. So for example, many of our customers use just this kind of setup for doing clickstream personalization. So the idea is that customers spent time on their website viewing 3 articles, maybe they've clicked on 4 things. What's the next best thing we can show them to maximize their engagement with the site? And this is a great opportunity to use predictive data in real time. So now what you've got is predictive analytics. Instead of Spark Streaming, you could use Amazon Machine Learning. You have a lot of flexibility there. Instead of Kinesis streams, you could use Kafka on EC2. It's really up to you, but all of the primitives exist to let you build comprehensive, complex applications that can run at very, very high scale. So that as a next step, we might think about securing our data. So using the AWS KMS, you can actually encrypt data at every stage. So data can be encrypted in S3. You can use KMS with EMR clusters to encrypt their data processing for data that sits on HDFS or is written to disk or is written to and from S3. And you can use KMS to provide keys for Amazon Redshift encryption at rest. So again, here you've got the ability to make sure that your data is encrypted at all stages in the chain when at rest, whether that's raw staging or actually in the analytic environments as available. And while this is illustrated using AWS KMS, it's just as easy to connect these systems, both EMR, Redshift, and actually S3 support running HSMs or hardware security modules, both in AWS as well as on-premise, and that can be used to inject keys into the system for your encryption. And then the next step around data protection would be protecting data while it's in transit and network isolation, so you can actually run these systems inside of VPCs. And so EMR clusters can run inside of VPCs in private subnets, as can Redshift, and then you can use VPN to bridge your external resources into your VPCs. And so now you have encryption at rest, you have encryption in transit, you can require SSL over the wire for your querying applications, and so you've got a complete secure chain end-to-end from that side. And so now, as you can see, it's very easy to use these building blocks to build sophisticated applications that you can scale each tier independently, and each tier doesn't have to exist right at the get-go. You can add things incrementally and really scale up as you need. And to contextualize some of this for you, the other thing that you get is the ability to really take advantage of technology as it becomes available. So for example, we've had customers move from running Hive to running Presto, and they're able to do that by just spinning up a second EMR cluster. They don't have to move any data around. They just point it at their Orc and Parquet files and they can get going. So a lot of future flexibility is made available to you by thinking about your big data applications in this component set of concepts. It's a couple of other considerations. So from a security perspective, you have your choice of key management, as I've talked about. Service managed is where you check the box, we manage the keys for you. AWS KMS lets you manage keys yourself using AWS services, and you can decide which users can access which keys for which services and how long they're valid and what your rotation policies are going to be. Cloud HSM is managed hardware security modules, where we keep the boxes up and running in a highly available state, but we have no access to the crypto. And then on-premise hardware security modules, where you have full access and control over the key management, and that can live outside of AWS. For in-transit, you can require SSL for any querying that you do, and all of the internal communication in AWS between services over SSL TLS signed requests. You can use VPC for network isolation, and then IAM for setting up permissions, and CloudTrail for auditing those permissions. And so a very comprehensive set of security features. And from a compliance perspective, as I mentioned, we support the broadest range of compliance worldwide. So whether you're US-based or working outside of the States, we have a range of compliance certifications to make sure that regardless of your workload and security policy, you can implement it on AWS as you need to for your organizational requirements. From a disaster recovery and availability perspective, EMR and Redshift clusters are designed for resilience, so we actually will monitor hardware, will automatically replace nodes on the fly. Redshift automatically replicates data between nodes so we can deal with drive failures transparently. It's continuously backed up to S3. EMR clusters, we recommend using S3 as your data store, so we can tolerate total cluster loss. You can just spin up a new one. If you have your data on S3, it's available in all of the availability zones in a region. So there you have, each availability zone has its own redundant power network cooling, so they're separated failure modes. So that gives you availability within a region. And then you can enable your data in S3 to be copied across AWS regions. And again, we only do this. We have features that do this, but you have to explicitly enable them to allow you to respect data sovereignty rules and regulations. But if you were a US-based company, for example, and you wanted to be primarily out of the East Coast but have backup in the West Coast, this would be very straightforward to implement. And you don't have to have all your resources running in the second region. You can actually spin up a Redshift cluster in 3 to 5 minutes, and we actually allow you to start querying that right away from a snapshot. And we're streaming data in the background. So if you think about a typical data warehousing workload where more recent data is queried more often, we actually prioritize those blocks being loaded back into the cluster. So most operational queries get back to normal performance Once just 1 to 5% of that data has been returned, and then we continue spooling data in the background. No laws of physics are being violated. If you needed to sum all the data, we would have to hydrate the cluster completely, but that's done in parallel. Each node is streaming data directly from S3 in that case. So a full range of options for building robust, available, resilient big data applications that support batch and real-time workloads that scale into the many tens of petabytes and beyond. And so now, we've talked a little bit about how you might do this. I want to show you how some of our other customers have done this to give you a feel for the kinds of things that, that are being done. So NTT DOCOMO is Japan's largest telco company, and they actually run one of the largest Redshift production workloads in the world. It's a 2 petabyte cluster, 125 nodes running out of our Japan region. The interesting thing about this is that all data is actually generated outside of AWS, and all data is queried outside of AWS. The data comes in over Direct Connect, which is the private lease lines that we talked about earlier. And then they essentially load it onto S3, and from S3 load it into Redshift. The other elements that you're seeing here are essentially to manage their data staging and ingest process. So they use MySQL process to control the loader, and then that data is moved from S3 into Redshift and then queried from on-premise. This is a very sensitive use case, and so they leverage pretty much every security feature that I've talked about over the course of the presentation as part of their deployment requirements. So they use VPC for isolation, VPNs for extending private address space, encryption, CloudTrail, and database auditing. And it's a very high-scale production use case for Redshift. Nasdaq is another Redshift and EMR customer. They actually migrated their on-premise data warehouse appliance, which was an expensive system, cost them over $1 million a year, and it allowed them to keep just a year of data online. They track about 4 to 8 billion rows per trading day, essentially every intraday tick on exchanges that Nasdaq manages. And they're using it for billing, surveillance, detecting bad actors, and general analytics. And as you can see from their architecture, going from left to right, left is their on-premise environment. Again, data is coming from outside of AWS. Nasdaq actually runs SafeNet HSMs outside of AWS. I think they run 4 of them in highly available configurations that provide keys into the system. They use SNS to control their data loading, which is our essentially event notification service. And data is brought into S3, loaded from S3 into Redshift, and the Redshift cluster is also backed up to S3. So this migration they're able to complete in 7 man-months. They're able to run at higher scale and lower cost than they're able to in their on-premise environment. And interestingly, Nasdaq is also augmenting the Redshift data warehouse with Presto on EMR and S3 to give them full SQL access. And there's a question that came in about why use Redshift in this context if you can have SQL access to the data in Presto. And it's really about providing the highest performance possible access to the data that's queried the most often. And so typically if you think about running Redshift clusters on SSDs, you can drive higher performance than you're able to using Presto. And that's a function of Redshift architecture and just relative maturity. So that's the reason that customers end up combining these architectures. If your tolerance, if your query sets require single-digit seconds versus faster, then running all of your data warehouse on S3 using technologies like Presto is absolutely a possibility. And so, for example, customers like Netflix will run 25 petabyte data warehouses using Spark and Presto directly on EMR on S3. They also do run Redshift in other workloads where they have higher sensitivity to latency and performance. So SmartNews is a Japanese media portal, one of the larger ones there, and I apologize, this is probably a little small, but I'll walk you through it. Essentially, they're combining information about users, about the activities that users are taking on mobile devices or on websites. So what are they clicking on? What are they viewing? They're looking at ads and how ads are tracked, and then metadata on the articles. So you'll see that essentially they're capturing event streams in real time through their APIs. They have user information from RDS, which is our relational database service, and they have data about ads and article metadata stored in DynamoDB. All of that is coming into a process that's loading that data onto S3, so it's put into FluentD and then spun onto S3, and also spun into Kinesis. So if we look at their batch layer for the moment, they have data coming into S3. They're using Airflow, which is an orchestration service that Airbnb built. And so they're using that to orchestrate the data flows. They use EMR to do the processing and then bring it into RC file format on S3, where they can query it using Presto. And that's connected to Chartio, which is their visualization layer. Similarly, if you look at their speed layer, data is coming into Kinesis. And from there, they're using Lambda, which is a serverless computing environment that we launched recently, which allows you to essentially run compute tasks or arbitrary code without having to think about maintaining instances or infrastructure. And so Lambda is listening to Kinesis for events, and it can send those events notifications through SNS to email or text, or in this case, they've also integrated it into their Slack channels. And then they're also using Spark Streaming on EMR to bring that real-time data, process it, move it into DynamoDB, and use that to then power their ad display and serving infrastructure. So you can see that it's a bit more complex than what we talked about in terms of building applications, but really the same set of services being used in this case as we talked about, and all of this is available to all of you to build applications in your environments. So I just want to provide you, I'm sure the slides will get shared out, but there's some really great resources on AWS as you think about building applications like this. The AWS Big Data blog has a lot of technical in-depth content and sample code around building big data applications, also goes into a lot of detail on machine learning and Spark. The reInvent sessions for big data have all been recorded. We talked a little bit about Nasdaq's use case. They spoke in depth about what they're doing and how they run Presto and Redshift using data that's encrypted on S3. Also an interesting presentation by FINRA, who's the U.S. equities regulator. They track 30 to 50 billion market events a day. And they use a combination of Hive on Tez on EMR and Redshift. There's the Marketplace, which is essentially an app store for the cloud where you can deploy BI and ETL applications for use, typically with just a few clicks for use with AWS infrastructure. And then we also have a broad array of partners that can help you scope, build, and deploy and manage applications, both a combination of global solutions integrators like Accenture and Capgemini, Cognizant, as well as more focused, specialized players in big data like Cloudwick and DataPipe and North Bay. So a broad range of solutions available to you. And in summary, what I'd like you to take away is that if you look across AWS and the Big Data Platform, we have a broad array of services that allow you to cover really any of the big data workloads that you might want to, whether they're reporting where you're looking back, real-time applications where you're trying to take action in the moment, and predictive applications where you're trying to decide what's going to happen next. We also allow you to build and scale incrementally, so get started with whatever you need at the time that you need it, knowing that you can scale up as far as you need to go, and have a full suite of security, auditing, encryption, and network protection capability to allow you to implement your organizational data policies in the AWS environment. And then finally, and most of our large-scale customers have some form of hybrid deployments where essentially they're running systems outside of AWS, they're bridging them into AWS using VPCs, and we allow you to run these in production at scale at very, very high volumes. So with that, thank you very much. I think we're moving into the Q&A phase. Please do complete the poll questions that are available to you, and I'll start walking through the questions. So, there are a few questions in here about roadmap items, and we don't typically comment publicly on our roadmap. I will say that in terms of Velocity on EMR, we're shipping updates every 4 to 6 weeks, and so staying as current as we can on Apache open source applications. And Redshift has its own release cadence, which is fairly high, but happy to follow up offline one-on-one if there's specific questions on the roadmap. From a, there's a question about when using S3 for Spark jobs, can you only retrieve parts of files, or will each node load entire files? So this is, you should be able to get, if your formats are splittable, you should be able to get to the relevant parts that you need to. And typically our customers will use a Hive metastore and partitioning in that sense in context with the file sitting on S3, and so they can access that data efficiently. And there's a question about whether EMR clusters can be elastically scaled while jobs are running. Yes, they can. So you have the ability to scale up and scale down, and we will resize up on the fly and down on the fly. We're also able to scale down HDFS down to the level where there's no risk of running out of space with the amount of data that you have in use. And EMR also has a smart resize capability, so we actually wait for nodes to drain work before we remove them from the cluster. And this is how we're able to do things like dynamically add spot capacity to your cluster in near real time, in minutes. There's a question about when QuickSight will be available to run with Redshift in VPN, and I apologize, I can't go into a lot of detail on specifics about future capabilities. I know the QuickSight team is in preview at the moment and working fast to get to launch, and I'm sure that capability is top of mind for them. And there's also, we talked about a question, and I think we've addressed it in terms of why you might want to use Redshift and Presto together. Typically it's to provide the highest performance access in the highest performance store, but retain full SQL capability over all of your data. One other area to keep in mind when EMR and Redshift often get used together is for ETL type scenarios. So you might have a situation where you have a data warehousing appliance on premise, and quite often these are used for data transformation and processing as well as production reporting and querying. And so Amgen, for example, has Teradata appliances on premise. They were using a lot of capacity on those for ETL. They move that ETL to EMR, and then they're able to bring that data back into Teradata so they can extend the life of the Teradata investment, and also then add Redshift for growth in future workloads. I think that covers the questions that have been presented so far. So happy to take any others if there are any still outstanding. So there's a question here about why Presto is used instead of Spark SQL. It's really up to the customer. Both options are definitely available. I will say that typically we have seen higher scale workloads from a SQL perspective on the Presto side, but both products are evolving quickly. Most often we see Spark SQL used when it's used in conjunction with accessing some of the other capabilities within Spark or ad hoc access to data. And there's another question about how, if we can go into a bit more detail on Presto and how it can be used with S3 and Redshift. So Presto is SQL on Hadoop engine. It's actually designed as a federated query system, so it has the ability to query a broad range of databases, and has got built-in support for S3. And then we've made some contributions, as have others, to Presto to help it work better with S3, read encrypted data, for example. So when you issue a SQL query on Presto, it actually begins executing immediately and starts streaming data directly in from S3 in response to the query. And Presto is quite scalable, so you can add nodes to your Presto cluster and maximize throughput that way. And it was actually developed at Facebook, and it's used to query their massive data sets. And so Facebook open sourced this, and this is available through EMR. And so by running Presto on EMR, you can transparently query data that's sitting in S3 alongside data that's sitting in Redshift. And a couple of other things. I think there's a pretty vibrant ecosystem around Presto. Teradata is contributing to it quite actively, and Airbnb has AirPal, which is a Presto query tool, and the details of that are on the Big Data blog. And so there is, there's a fair amount of support for that, and it's a project that's evolving fast. And generally at high scale, high concurrency workloads for SQL on Hadoop, we've seen a lot of interest in Presto. But Hive on Tez, Spark SQL are all good options as well, as are things like Grill. And so there's a broad range of options. Again, all of them can be installed on EMR clusters and used that way. There's a question about embeddability and QuickSight. I believe QuickSight does support embedding, but I think we'd have to get more details from that team, so we'll be happy to follow up on that. And there's a question about sample pipelines for real-time audio processing. So I would, I would suggest probably doing some research on the AWS Big Data blog. I think there'll probably be a number of open source toolkits available for audio processing. I might also consider looking at some of the Alexa SDKs, which is Amazon's audio service. I know we provide some tooling on that front for that. So there's a question about whether Redshift and EMR are in the free tier. So EMR is not. However, Redshift does provide a free trial for customers who are new to Redshift, so you can run for a couple of months free with reasonably sized workloads, and that should be available on the Redshift detail page. So that should take care of that particular use case. So there's a question about whether there are case studies to understand change detection and update, for example, to deal with a stream of changes coming into a data lake and update them. So the answer here is yes, and I would definitely suggest checking out the AWS Big Data blog. Interestingly, S3 provides the ability to generate events when new objects appear, so that's a way of capturing changes. DynamoDB provides streaming changes, and so you can essentially use events to detect change and then have those events trigger actions that will, for example, update a data catalog with new data coming in. So the Big Data blog, S3 events, and AWS Lambda are the right set of places to look for that and for more case studies on that front. Let's see if there... let's see, any other questions? So there's another question about if there are case studies outside of media and financial. Absolutely, there's a range of enterprise, biotech, manufacturing, machinery, and those are all available through the AWS case studies site, and the Big Data blog will have a number of those as well, where we'll go into more technical detail on the specifics of that. There's a question about if you're using Presto, do you have to keep EMR running 24/7? You do not, because essentially your data is sitting on S3, so you can instantiate clusters when you need them and spin them down when you don't. And I mentioned FINRA, for example. They expand the size of their cluster during market hours on the East Coast and then spin it down after the market hours are done. Similarly with Presto, you could have smaller clusters that are always on that you can scale up when needed, or just shut them down when you're not looking at it. There's a question about having data on S3 and EMRFS and whether you need to load it into EMR to use it. The answer is no, that's transparent. So you just provide a file path and access to the data, and EMRFS will take care of exposing that data to the Hadoop application stack. So it's completely transparent, and for analytic workloads, we actually find that performance can be pretty dramatic on that front, and you have all of the benefits of being able to run multiple clusters on the same data. So there's a question about machine learning and machine learning on Spark or the Amazon Machine Learning Service or anything on EC2. In terms of machine learning on Redshift, essentially the way that you would do this is either implement it using SQL, or Redshift also has support for Python UDFs, and it ships with Pandas, NumPy, and SciPy as built-in libraries. So as long as you can express what you're trying to do in Python, you should be able to do it on Redshift via user-defined functions. So there's a question around performance benchmarks of query time on Redshift versus Presto Parquet. So typically with databases, performance is really a function of data sets and query types. A place I would recommend checking out is the Berkeley AmpLab benchmarks for big data. So they benchmark Redshift versus a number of other open source SQL technologies. And from a Presto Parquet perspective, the Big Data blog and the reInvent presentations have a number of use cases in that area. So there's a question about big data training. So we do have big data training that's available through AWS Training, and you can get certification in those areas. And we do provide details and deep dives into these tools. And I think that's a great starting point for getting familiar. And then you can engage through your account teams and solution architects and the Big Data blog. And we're always reachable on Twitter and elsewhere through our forums to provide specific one-on-one help as needed. And I think with that, we're coming to the end of the hour. So I want to thank you all very much for your time and attention. Really appreciated the opportunity to chat with you all.
I'd like to extend a special thank you to our presenter Rahul for his time and a great presentation, and also to Radhika for answering the audience's questions. If you have any comments on our previous and upcoming webinars, or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email aws-webcasts@amazon.com. Your feedback will help us to improve our future webinar programming. Thank you to our audience for taking the time to join us today, and enjoy the rest of your day.